In this presentation, we'll just go over the solutions to the second set of practice problems. So looking at the first problem here, we've got our two assumptions, and then our conclusion is a tilde. So we want to assume the whole opposite of that, so it's going to be P and S. And we're going to do PA, number 3. Now, next thing I would do, because I see the P and S are my two antecedents, I just go ahead and break this up to ampersand out. So from 3. Now I can toss each one of these into the conditional statements. I can toss the P into 1 to get Q and not T. And that's going to be from 1 and 4, arrow out. 1 and 4 is 1 and 3. And then I can get T by itself from 2 and 5, arrow out. 2 and 5 is going to be 2 and 3. And then I can get the not T out from 6. Percent out. So it's going to be 1 and 3. Then now I've got my contradiction. So that's going to be 7 and 8. Ampersand in. And then it's going to be 1, 2, and 3. And now I got my contradiction. I got the PA that depends upon it. So can tilde in for my 3 and 9. Tilde in. 1, 2, and 3. And then that drops out. The 3 drops out like so. And that is this first proof. Just one assumption in this proof. So still the same plan. We've got a tilde in front of our Q and T. So line 2, we'll just write Q and T. That's going to be a PA. We're going to look for a contradiction. First thing I would do is break this up. And the Q and T. Sorry, not 3, 2. And out, 2 and out. 2 and 2. Now, I mean, I'm doing this because I could see that I'm going to be able to get this from my conditional out. Oh, sorry, I need the tilde next to it, or this isn't going to work out. So I can see that this is one part of my possible contradiction, S or T. And so I should be looking to get S or T, and I can build that with just my T here. So I could do S or T from 4, wedge in. And right there, that's going to be my contradiction between these two. But I still got to get this S or T out. So I got to build the antecedent to the first line conditional, and I can do that with my Q from line 3, wedging in. It's going to be 2. And then with 1 and 6, I can get my tilde S or T. So that's going to be 1 and 6, arrow out. 1 and 6 is 1 and 2. And then I've got the potential for my contradiction. I just got to put them together. Doing 5 and 7, ampersand in. 5 and 7 is 1 and 2, and then I can just tilde in on my PA. And so we remove the 2, drop it out. So it's just going to be 1, and that is proof 2. Moved on to 3. We've got 2 premises in this one. So we've got these 2, and then our conclusion has a tilde in front of it, so we know we're going to assume it's opposite and look for contradiction. So I'm going to go ahead and separate S and P out because those are going to be my 2 antecedents for the conditionals that are trapped inside of 1. So that's going to be 3 and out, 3 and out. Now I can take P, toss it into 1 to get S arrow, not T. Whoops. Yeah, I know, that's right. So this will be 1 and 5, arrow out. 1 and 5, have 1 and 3. Now I've got S, and I can toss that into this S arrow T, so that's going to be 4, 6, arrow out. 4 and 6, have 1 and 3, and then I can take this dot T and T, put them together to build my contradiction. That's 2 and 7, ampersand in. 2 and 7 have 1, 2, and 3. And then now I've got a contradiction. My PA depends upon, or the contradiction depends upon the PA, so I can tilde in on my PA. That's going to be 3 and 8, tilde in, 1, 2, and 3, but the 3 will drop out once I do tilde in, so it's just 1 and 2. So we got 2 premises here. And our conclusion is a tilde. So we know we're going to assume it's opposite, look for a contradiction. So I've got 2 conditionals in 1 and 2, but I can build both of their antecedents. So I can do P wedge Q and Q wedge P, both of them from 3 wedge in. Clean that up a little bit. Then we can toss each one of those into their associated conditional statement. So we can get S and not T from, looks like 4, 1, 1 and 4, arrow out. It's going to be 1 and 3. And then I can toss Q or P into the conditional statement 2 to get not S. So that's going to be 2 and 5, arrow out. 1, 2, and oops, nope, just 1 and 2. Right? 2 and 5. Nope, just 2 and 3. And we're still looking for a contradiction. We can get the S out of 6. And so now I've got S and not S, so I just got to put them together. Doing 7 and 8, ampersand in. That's 1, 2, and 3. I've got a contradiction now. It depends upon the PA, so I can tilde in on the PA. So it's going to be 3 and 9, tilde in. 1, 2, and 3. Move the 3 because it drops out with tilde in. And that is problem 4. Here we've got 3 premises. So let's get all those written down first. Now, our main operator is that outside tilde, even though we got 2 there, where the most outside one is the main operator. So what we're going to do is we're going to assume the opposite, which in this case would be not S. So we're removing that front tilde, and we're going to look to add it in at the very end. So we still mark this as a PA. Appears on line 4, so it gets associated with line 4. And now we're just doing the same thing as before. We're looking for a contradiction. Well, I can put my P and S together, or P and not S together, from 3 and 4. ampersand n. And then I can take this and put it into my conditional statement 1 to get t. So that's going to be 1 and 5, arrow out. 1 and 5 is 1, 3, and 4. Now I can take just the regular p and put it into 2 to get not t from 2 and 3, arrow out. 1 and, oops, sorry, nope, 2 and 3. And now I've got a contradiction with t and not t from 6 and 7, ampersand n. 6 and 7 is 1, 2, 3, and 4. And then now I've got a contradiction. It depends upon my PA, so I can add an extra tilde in there. So that's going to be from 4 and 8, tilde n, 2, 3, 4. The 4 drops out because that's my PA number, so it's just 1, 2, and 3. Here we got two premises, so let's write those first. Not S, that's wrong. Our main operator in our conclusion is a tilde, so let's write the opposite of that conclusion. So it's going to be P and not R. It's a PA. Now, next thing I would do is I would just separate this P and not R, because I got to get the antecedents for my two conditional statements. I'm going to need them both for it, so now to get the conditional out of 1, I need to wedge in the Q first on the P, so that's going to be 4. Wedge in. And then I can take this, I can toss it into the conditional to get S by itself from 1 and 6. 1 and 6. Arrow out. 3. Next, I can take the not R, toss it in the conditional statement in 2 to get T and not S. So that's going to be from 2 is my conditional statement, 5 is my antecedent, doing arrow out. 2 is next to 2, 3 is next to 5. Now I need the not S from that conjunction, so I'm going to do 8 ampersand out. And then I need to put both of those together. S and not S. Oh, I gotta finish this real quick. And then that's gonna be from 7 and 9, ampersand N. 7 and 9, that's gonna be 1, 2, and 3. And then we want to introduce a tilde in front of our PA, so that's going to be 3 and 10, tilde N, 1, 2, and 3. 3 is going to drop out because that's my PA, so it's going to be 1 and 2. Here we got two premises, so let's write those. Our conclusion is just a tilde Q, so we'll assume the opposite. Mark as a PA. Look to get a contradiction. So, probably first thing I'm going to do is break apart the ampersand there in 1. Like that, because then that gives me the antecedent for my conditional in line 2. So I can write Q arrow S from not 1, but 2 is my conditional. And 4 is my antecedent, doing arrow out. 1 and 2. Now I've got the antecedent for my Q arrow S. So I write S. So it's going to be 3 and 6. Arrow out. So it's going to be 3, 6. It's 1, 2, and 3. Now I can build my contradiction from 5 and 7. Ampersand in. 1, 2, 3. I got my contradiction. Just needed tilde in on my PA. So that's be 3 and 8. Tilde in. 1, 2, and 3. 3 is going to drop out and should be 1 and 2. These last 3 proofs are a little bit more challenging. They're supposed to be a little bit more fun. And they require a little bit more thinking. So for this proof, let's go ahead and start off how we start off every proof by listing our assumptions. And then let's look at our conclusion. The main operator in our conclusion is the ampersand. So I have these 2 things I'm looking to prove. So I'm looking to prove not P and not Q. I need to prove them separately, and then from there I can put them together using my ampersand in rule. Well, means that we are looking to prove 2 tilde ends. So we need to do them one at a time here. So what we're going to do is we're going to start off with our not P, and we're going to assume the opposite as a PA and look for a contradiction. So with this, I can toss it into line 1 to get S. So that's 1 and 4, arrow out. 1 and 4. Now I've got a not S that's attached to this T in 3. So let's free that up from 3 ampersand out. And then I can build my contradiction from 5 and 6 ampersand in. So that's 1, 3, and 4. Now I've got a contradiction. It depends upon my PA, which was the P, so I can tilde P. So that's going to be 4 and 7, tilde in. 1, 3, 4. The 4 will drop out, so it's just going to be 1 and 3. So that's 1. Now we need to get to not Q, so we do the same thing. We assume it's opposite. It's a PA. And then we look to get a contradiction. So we can get not T from 2 and 9, arrow out. 2 and 9. Then we can get the T from line 3, doing 3 ampersand out. That's just going to be from 3. Now we got our contradiction. We got T and not T. So we can build that doing 10 and 11 ampersand in. 10, 11, that's going to be 2, 3, and 9. Now I've got a contradiction, and it depends upon my PA, which was Q. So that's going to be 9, 12, tilde N. So 2, 3, and 9, but the 9 will drop out, so it's just going to be 2 and 3. And now I've got the not Q, so I just need to put them both together. I got not P and not Q. And so that's going to be from 8 and 13 ampersand N. And that's going to be 1, 2, and 3. So that's problem 8. This is going to be another sort of tricky one because the conclusion's main operator isn't a tilde. So we got to think about what we need to do to get to the conclusion. We've got 3 premises here. And now let's look at our conclusion. Conclusion is a wedge. So if you remember when we were trying to prove wedges, that's telling us we need to find either not P or T and then wedge in the other. Well, when we look at our proof, I don't see a T anywhere in any of those premises, so that's not going to be helpful whatsoever. So instead, I need to prove not P and then wedge in the T at the end. I don't see not P written in any of these assumptions, so I'm going to have to just look to prove it. So how do I prove not P? Well, I assume it's opposite and look to build a contradiction. So I can get S from 2 and 4, arrow out, 2 and 4. And then I can put P and Q together from 3 and 4, ampersand N, 3 and 4. And then with that, I can get my not S out of 1. So that's to be 1 and 6, arrow out. 1 and 6 is going to be 1, 3, and 4. And then we can build our contradiction, S and not S, doing 5 and 7, ampersand N. 5 and 7's 1, 2, 3, and 4. Then we can tilde in on our PA, so it's going to be 4. Oops, sorry. That is not right. That's going to be 4 and 8, tilde N. I was getting ahead of myself. 1, 2, 3, 4, but 4 will drop out. So just 1, 2, and 3. And then we can wedge in our T from 9, wedge in. 1, 2, 3. So that's problem 9. So again, we had to identify the main operator. In this case, it was the wedge, the tilde P, wedge T. The tilde was the main operator. And then from there, we needed to prove one of those disjuncts and then wedge in the other one. And so that's what we did. We figured out that we couldn't get T out of anything. So we needed to just focus on the tilde P. So we looked to prove the tilde P by doing our tilde N rule. And then from there, we just went ahead and proved the tilde P and then built the disjunction that we were needing. Now, this is a pretty complicated proof as well. Again, just sort of have to follow our instincts and game plan that we set out at the very beginning by looking at the conclusion and what we have. So we have 2 premises, and then our main operator in this conclusion is this ampersand. So I need to prove this and I need to prove this. So I'm looking to prove not P and Q, and I'm looking to prove Q arrow tilde S. Let's just do them one at a time and then we'll ampersand them at the very end. So starting with the not P and Q, well, the main operator there is a tilde, so we're going to assume the opposite as a PA and then look to get a contradiction. So I can toss this into my conditional here in line 1. So I got 1 and 3, arrow out, 1 and 3. Then I can also separate out this Q from 3, ampersand out, and I can wedge in the T to that Q. So 5, wedge in. Next, I can toss this into my conditional statement in line 2 to get not S. So that's going to be 2 and 6, arrow out, 2 and 6, 2 and 3. Then I can put these two together, S and not S. That's going to be 4 and 7 ampersand in. There's my contradiction. It depends upon my PA, so I can do tilde P and Q. And so that's from 3 and 8, tilde N. 3 is my PA, 8 is my contradiction. 1, 2, and 3. 3 drops out. So we're just left with 1 and 2. So that's one part of our conjunction. So let's build the second part. Now, if I've got an arrow statement, how do I prove an arrow? Well, I assume it's antecedent as a PA, and I look to get the consequent. So my consequence tilde S, I can get that from doing this conditional out statement. So I want to wedge in my T to 10, wedge in, and I want to get my tilde S out from 2 and 11, arrow out, 2 and 11. Oh, sorry, nope, it should be a 10. Now I've got my antecedent and I got my consequent, so I can arrow in. So that's going to be 10 and 12, arrow in, 2 and 10. The 10 will drop out because we're doing arrow in, so it's just going to be line 2. And now I've got this one, and so I just kind of put them together. I'll offset them here. And that's going to be from, looks like 9 and 13 ampersand in. So it's 1 and 2. And that is our proof for this one. Now you might be wondering, why did I have to get this twice in my proof? So you couldn't have built the conditional statement here in line 11 because you have this tilde S, because this tilde S over here depends upon the third PA. So it doesn't depend upon this PA. It doesn't depend upon the Q. It depends upon the 3, or the line 3, the first PA that we made. So your consequent needs to depend upon the PA in which you're trying to build the conditional statement. So that's why we had to get not S again and then build our conditional statement from there. But this is a pretty complicated problem, but it shows you how we can start using our rules and our intuitions by looking at the conclusion to start working towards more complex proofs. So that concludes this second set of practice problems here.